Hello students, the question is assertion. The energy of a charged particle moving in a magnetic field does not change. Reason. It is because the work done by the magnetic force on the charge moving in a magnetic field is zero. So the problem is based on the topic, the moving charge under the influence of magnetic field, the force on the charge in a magnetic field. So first of all, the assertion is given that the energy of the charged particle moving in a magnetic field does not change. So let us take a situation here. For example, there is a magnetic field. Let us take this magnetic field to be perpendicular to the plane of the board. And suppose any particle enters this field, this uniform field. So when it enters the uniform field, a force starts acting on it. And this force is given by this expression F equals to Q V cross P. So in this way, this force is perpendicular to the direction of the velocity of the particle as well as the direction of the magnetic field. So in this way, the particle experiences a force which try to move this particle in a circular path like this. So the particle moves in a circular path. Suppose the field is very large and the particle, it covers a complete circle. So in this way, we can say that it is moving in a circular path. And when it is moving in a circular path and follows this circular path continuously, and it does not change the radius of the circular path, it means that the energy is neither increasing nor decreasing. Because if the energy is going to increase, then the particle's radius would increase continuously, but it is not the case. Similarly, if we assume that the energy of the particle it goes down, then the particle, it is moving in a spiral like this. It should move in a spiral like this, and its energy goes down and down. It will lose its all energy reaching at the center, but it is not the case. The particle always move along the circular path like this in a magnetic field. So the assertion is perfect. The assertion is correct that the energy does not change. Energy of a charged particle moving in a magnetic field does not change because it is moving in a circular path and the radius of the circular path is not changing. The explanation given here or the reason given here is also favorable to the assertion, because in the reason it is said that it is because the work done by the magnetic force on the charge moving in a magnetic field is zero. So the magnetic force, it is not doing any work on it. The reason being, if we want to calculate the work done, so work done is equal to F dot D, where F is the force and D is the displacement vector. And if we check the direction, we check the angle between F and D, then this is 90-degree angle. So F dot D means FD cos theta, FD cos theta, where theta is the angle between F and D. Now what is force here? Force is the centripetal force, which tries to move the particle in a circular path. So this is a centripetal force always acting along the this direction towards the center. So this is the direction of the force, this is the direction of velocity, and the direction of the magnetic field is perpendicular to the plane of the board. So in this way we can say that all the three vectors are perpendicular to each other. And we have to focus on the force and the displacement vector. Force is towards the center and the displacement is at the 90-degree with this particular force. So theta is 90-degree, it means that cos 90 is 0, so the work done is 0. So work done by the magnetic force in this situation is 0. So in this way we can say that the particle retain its energy and move in the circular path continuously. So the reason is perfect explanation of the assertion. So we can say that assertion and reason both are correct, and in assertion and reasoning based problems, when assertion as well as reason both are correct, then you have to choose the option A. And the assertion is also, and the reason is also the correct explanation of assertion, then we have to choose A. So यहाँ पे प्रॉब्लम पूछी गई है मूविंग चार्ज अंडर द मैग्नेटिक फील्ड, फोर्स ऑन अ मूविंग चार्ज अंडर मैग्नेटिक फील्ड टॉपिक से। इसमें असर्शन में कहा गया है एनर्जी ऑफ अ चार्ज पार्टिकल मूविंग इन अ मैग्नेटिक फील्ड डज नॉट चेंज, यानी पार्टिकल की जो एनर्जी है उसमें कोई बदलाव नहीं आता है। ये असर्शन है, ये बिल्कुल करेक्ट असर्शन है, करेक्ट स्टेटमेंट है, क्योंकि पार्टिकल कभी भी अगर किसी मैग्नेटिक फील्ड में एंटर करता है इस तरह से, तो अकॉर्डिंग टू इक्वेशन F बराबर क्यू वी क्रॉस पी के हिसाब से इस पर एक फोर्स लगता है जो इसको एक सर्कुलर पाथ में घुमाता है। और इस सर्कुलर पाथ की जो रेडियस है उसमें कोई बदलाव नहीं आता है। तो उस कंडीशन में हम कहेंगे कि अगर रेडियस में कोई बदलाव नहीं आ रहा, इसका मतलब उसके ऊपर उसकी एनर्जी में जो है कोई भी बदलाव नहीं आ रहा है। तो ये स्टेटमेंट बिल्कुल करेक्ट है। एक्सप्लेनेशन में दिया गया है कि उस पर जो मैग्नेटिक फोर्स की वजह से जो वर्क डन होगा वो जीरो होगा। मैग्नेटिक फोर्स की डायरेक्शन है अलोंग द सेंटर और पार्टिकल मूव कर रहा है अलोंग द परपेंडिकुलर टेंजेंट डायरेक्शन। तो अगर कोई भी कंपोनेंट इस पार्टिकल की वेलोसिटी का अलोंग द सेंटर होता तो पार्टिकल का पाथ चेंज हो जाता। लेकिन क्योंकि पार्टिकल की वेलोसिटी जो है वो परपेंडिकुलर है, तो उस केस में मैग्नेटिक फोर्स द्वारा किया गया वर्क जो है वो जीरो है। अदरवाइज जो पार्टिकल मूव कर रहा है उस सर्कुलर पाथ को एज इट इज फॉलो करता रहेगा। सो यहाँ पे रीजन जो है वो बिल्कुल करेक्ट एक्सप्लेनेशन है असर्शन का। हम कह सकते हैं यहाँ पे असर्शन भी सही है, रीजन भी सही है, और रीजन जो है वो करेक्ट एक्सप्लेनेशन है असर्शन का। तो इसलिए हमारा ऑप्शन ए यहाँ पे करेक्ट होगा। सो होप यू अंडरस्टैंड द एक्सप्लेनेशन। थैंक यू।